A general rule of thumb with geometry problems is that if there's no picture drawn from you, it tends to be an easier problem if you can just draw the picture. So I've got here two triangles, and I'm going to draw one of them. Here's triangle ABC. All right, and I'm told that the side lengths are 11, 13, and 18. So let's just put some numbers on here, 11, 13, and 18. And on top of that, there's a similar triangle. That's a very important word. Where are we here? It's a similar triangle, okay, DEF. So what I'm going to do to draw a similar triangle, this is cheating. You can't really do this, but I can. I'm going to take my triangle ABC and just stretch it or shrink it however is appropriate. And I think in this case, we want it a little shrunken. I'll shrink it more to make it obvious. Okay, there we go. So I've got this similar triangle. It's shrunken now. This is DEF. Same shape, just different lengths. And DEF has a short side of 9.9. Okay, so instead of 11, it's 9.9. And it wants to know what's the perimeter to the nearest integer unit of DEF. So here's my letters. I just want to know what the perimeter of this thing is. Well, you can do this two ways. You could calculate what these missing sides are, right over here, and then you could add the whole thing up. Or you could find the perimeter of the first triangle, ABC, and multiply it by a certain ratio. It doesn't matter which way you do it. I'll do it the other way first. I'm going to call this side over here X, all right? And I'm going to say that the ratio of these two triangles is constant because they are similar triangles. So that means 11 divided by 9.9 is the same as 13 divided by X. See how those are corresponding sides? And now I'm going to multiply each of these fractions by something to get rid of the denominators. I'm going to multiply the right side by X and the left side by 9.9. Now you can't multiply different sides of the equation by different things. They have to be the same multiples on each side. So I handle that by multiplying both sides by X and both sides by 9.9. Well, the X's cross out on the right, the 9.9's cross out on the left, and you get this form, 11x equals, well, 13 times 9.9, which is equal to something. 13 times 9.9 is going to be 128.7. That's what 11x is. And therefore, x equals, divide this thing by 11, and there you go, 11.7. So that's one way you can do this. And then you would repeat that process for this other side over here. Call that y. Whatever. That's one way to do it. And then you add them all up, you got the perimeter. A quicker way to do it is to do it this way. For this triangle, ABC, the perimeter equals 11 plus 13 plus 18, which means that is plus 13 plus 18, just don't want to make any mistakes here. That is 42. So a perimeter of 42, you set up the following equation. You say 11 over 9.9. Okay, that's the ratio of the lengths of the two triangles, equals the perimeter of the first triangle, perimeter of ABC, divided by the perimeter of the second triangle, DEF. Okay, rewriting that equation, we get 11 over 9.9 equals 42 over the perimeter that I'm looking for. And now, with some more multiplication stuff, you can solve this problem. And I'm going to rewrite this and say 11 times the perimeter I want equals 42 times 9.9, which is 415.8, and the perimeter is that thing divided by 11. Okay, it's a faster way of doing it, and what it requires is for you to recognize that if the sides are proportional, then so must be the perimeters proportional.